Hello everyone, we are here to present our project titled Energy Consumption Forecasting. In this project, our goal was to accurately predict electricity usage patterns using time series analysis and machine learning techniques, specifically LSTM neural networks. Accurate energy forecasting is essential for efficient power grid management, planning, and sustainability. Through this project, we explored historical energy consumption data and built a predictive model capable of forecasting future demand. With rising electricity demand and an increasingly complex power grid, efficient energy management has become critical. Accurate forecasting of energy consumption helps in balancing supply and demand, reducing operational costs, and enabling better integration. This is especially relevant today as utilities aim to improve reliability and sustainability. Objectives. The main objectives of a project is to develop a predictive model that can forecast hourly energy consumption. To achieve this, we used historical electricity usage data and trained a model to generate forecasts for the upcoming 30 days, helping decision makers in proactive energy planning. Now, further information on the same will be given by my teammate Hardik.
Hello everyone. So I'll be explaining about the data set that we have used. We used the PJM hourly energy consumption data set, which includes around 1,45,000 hourly records from 2002 to 2018. Each record represents energy usage in megawatts for a particular hour. The data set reflects various patterns influenced by seasons, weekdays, weekends, and holidays, making it highly suitable for time series forecasting using LSTM models. Now let's have a look at tools and technologies used in this topic. Our project was built using Python on Google Colab. We used TensorFlow as a tool and Keras for building the deep learning model, Pandas and NumPy libraries for data manipulation, and MinMax scaler for pre-processing. Visualization was done using Matplotlib library, and these tools collectively enabled us to handle and model time series data efficiently. Now, further information will be provided by my teammate Rhythm Jain.
Greetings everyone. My name is Ridham. So let's start with the implementation workflow. So the first step in implementation workflow is data loading and data visualization. So here we have imported the dataset and plotted energy consumption over time to understand patterns. The second step we did was data normalization. So here we applied min-max scaler to scale the energy values between 0 and 1, facilitating faster and more efficient model training. The third step we performed was sequence creation, where we created sequence for 24 hours interval to predict the subsequent hours energy consumption. The fourth step is data splitting, where we divided the data into training and testing sets. The fifth step we did was model building. Here we constructed a sequential LSTM model with two LSTM layers performed by a dense layer. The sixth step was model training, where we trained the model for 10 epochs with a batch size of 32. Then we performed model evaluation to evaluate the model's performance using mean squared error on the test set. The last step was forecasting, which utilized the trained model to forecast energy consumption for the next 30 days on an hourly basis. So now let's see the code. So in this part of the code, we have imported the necessary libraries and uploaded the CSV file necessary. We have also written the code to read the file. So the next part of the code, this code first plots the original hourly energy usage, giving a visual overview. Then it scales the energy data between 0 and 1 to prep it for training. Finally, it slices the time series into sequences of 24 hours to predict the next value and reshapes the input to fit the LSTM model. Basically, it's getting the data all dressed up for the prediction party. So now my teammate Vivan will continue.
Hello everyone, I am Vivan. So basically, we have split it up into 80% training and 20% testing data. Then we built a sequential LSTM model with two LSTM layers followed by a dense output layer. The model was compiled with the Adam optimizer and trained over 10 epochs with a batch size of 32. After training, we made predictions on the test data and scaled them back to actual values using inverse information. So once the model was trained, we used it to generate a 30-day forecast data. Starting with the last 24 hours of real data, the model predicted the next value and fed it back in as input. Continuing this process for 720 hours, the forecasted values were then inverse scaled and flipped to remove any negative values. A time index was also generated to match the forecast timeline. Now my teammate Krish Kapadia will guide you ahead.
Hi everyone, my name is Krish Kapadia. So here we now visualize the model's prediction as you will see further in our results. So forecast visualization. So we've generated a 30-day forecast, generated hourly forecast for the next 30 days using the trained LSTM model. Visualize the forecasted energy consumption alongside the recent actual data to provide context insights. The forecast indicates expected daily and weekly consumption patterns. Such forecasts can aid in proactive energy management and planning. So now we'll talk about the result analysis that we've achieved. So the model effectively captured the temporal patterns in the energy consumption data. The mean squared error on the test set indicates a reasonable prediction accuracy. And we've plotted the actual versus the predicted energy consumption values to assess the model's performance. The forecasted values closely follow the actual consumption trends, demonstrating the model's efficacy. So now I'll just show you the collab file. So here we first install the basic requirements and dependencies. And then as you scroll down, you can see that we've loaded the data set. We've converted the date time. And here we've performed our main operation. And as you can see, we've built the LSTM model and we've done a 30-day forecast. And we've ran 10 epochs. And this is our results, which we will also see in the PPT ahead. Yes. Next slide. Now first we see our energy consumption plot. This shows energy usage over time. This was trained for 10 epochs, and as you can see, the loss decreases during each epoch, and thus showing that our model is working very perfectly. Here we've predicted the actual versus the here we forecasted the actual versus predicted energy consumption by our trained model. And here we have two plots of the forecast, one against the actual and 130-day predicted energy consumption as per our model. So to conclude our project, we've successfully developed an LSTM-based model for forecasting hourly energy consumption. The model demonstrates satisfactory performance in capturing consumption patterns and generating future forecasts. This approach can be instrumental for energy providers and grid operators in decision-making processes. Thank you.